To our webinar today, the new science of predictive analytics and cybersecurity operations centers. And we'll spend the next 45 minutes or so together, and we're going to get this thing kicked off. And we continue to have some folks join, so they'll just be joining as they can. Thanks for attending today. We have a really interesting topic to talk about today, but before we get to a little housekeeping, there is a Q&A feature embedded with the webinar. It's a link that you'll see that allows you to ask questions. We will hold off on addressing any questions till the end so we can keep the momentum of the conversation going, but we will allow for questions at the end. So do submit questions if you have them along the way. We are going to record this as well, so this will be available for anybody that would like to receive that. There's also an option at the end I'll talk about, a white paper that you can download or receive a copy of if you'd like to do that. But we're fortunate today to have a couple of folks on the call that are subject matter experts, if you will, in the field of predictive analytics, cybersecurity, IT, networks, etc. And so our conversation today will really be about, how do operators of network operations centers, security operations centers improve their situational awareness to mitigate risk that they have that's surrounded by the cybersecurity threat that we all face today, corporations, the government, higher education, universities, the list goes on. And so with that, what I'd like to do is introduce you to Kevin Yin and Nathan Jones, and I'm going to let both of those guys do their own introduction because they can speak better for themselves than I would be able to speak for them. So let me start with you, Kevin, hoping you can hear me. Kevin, are you there?
Yes, I'm here. Can you hear me? Hello?
Yep, we got you, Kevin.
Can you hear me?
Nathan, maybe you. Let's start with you. Can you hear me?
I can hear you, and I can hear Kevin as well.
Yeah. Can you hear me? I'm Kevin here.
I hear you,
Robert,
Kevin.
can you hear me?
I hear you fine. Go ahead, Kevin.
All right. Maybe Robert has a challenge to hear me, but that's okay. I'm Kevin Yin, CEO of Seascape. My experience over the last 20 years are mostly in information technology, software products, internet startups, and financial services, and the DoD and military systems, and mission critical systems. So I have spent a lot of time designing and deploying and supporting customers in mission critical environment using data, technology, and software and analytics. So I'm very much appreciate the opportunity today to talk to you guys today about this subject.
Fantastic. And I'm Nathan Jones. I'm the Director of Sales for the Intelligent Technology Solutions Division of Diversified. Like Kevin, I've been in the IT industry for a little over 20 years now, ranging in experience from the large enterprise down to the micro, small startup. And from networking over to software. But, over the last 5 to 6 years specifically been focused on providing IT services for small, mid-size, and enterprise clients. And, in that, not focused on cybersecurity, you're pretty much living under a rock. So have been a student of and very interested in where cybersecurity is going, particularly with the growing threats that are out there. So thanks for having me today.
So Nathan, thanks for that. Can you hear me okay?
I can.
Yeah, I don't know what happened there. I apologize, everybody, but I had a little bit of an audio glitch, so sorry about that. I missed part of your introduction. Did Kevin get a chance to introduce himself, or did I kind of jump the gun on that one?
Kevin did as well.
Yeah, I did. Can you hear me?
I can hear you now, yeah. So again, apologize about that little glitch in the audio. Not sure what happened, but I couldn't hear either of you. But we got it working now, so hey, thanks for the introductions there. And You two both bring a wealth of knowledge and information to the table, and I think maybe what we should do, let's just dive right into this thing. And what's interesting is that I did a little bit of reading. Cybersecurity is an area that I'm very interested in, and it's kind of interesting. Not too long ago, I read an article by a woman named Lily Hay Newman, who writes for Security Magazine, but she had written an article that I'll share with you, and this would be a great place for us to start, is that network security isn't getting better fast enough, and its critical infrastructure is sort of hanging in the balance. And basically what this is saying is that hackers are getting better and bolder and more sophisticated, that we can't keep up with it. And, I think there's a lot of truth to that. And she goes on to basically showing some examples of some pretty brazen attacks that have happened. If you guys recall, earlier in the year, a Russia attack on a power grid. I'm not going to read through all of this, but it's an example, or one example, of our grid being attacked by a foreign government or operatives within a government. And she goes on to talk about another attack that was undertaken by some Iranians, and they've defined it as being a state-sponsored attack, cyber attack on universities as well as some private companies. That was pretty significant the way they described it. And then the last one that I'll point out is it's a private company, right? A corporate attack. And now what's interesting about Under Armour and this attack was that they thought they were doing all the right things, and they did actually do a lot of right things after they had gone back and kind of looked at the history of this attack and what they had done, what could they have done better. And they had made a few mistakes thinking that they had covered all the bases, and in fact they hadn't. And so it's just sort of a stark reminder that you can never do too much to stay aware of and or be upgrading your policies and or technologies for the cyber world we live in. And so, with that being kind of said, and a backdrop for this conversation today is, how do you get better at it? What are the technologies and solutions out there that are allowing corporations, governments, et cetera, to do a better job, getting out of a place where they're being reactive and being more, predictive in what they're doing and preemptive in some ways. I think that's a great place for us to start this conversation. So what I'd like to do is, this is going to be more of a town hall type session where I'd like to ask you guys some questions and have a conversation with you around this topic. And maybe what we do as a starting point is, at the core of what cybersecurity is, it's really, fairly simple. It's measures that are taken to protect computers or computer systems, networks is what they're really saying, right? From unauthorized attacks or intrusion for any malicious purpose. And that's the very, very basic part of what cybersecurity is. But cybersecurity has really grown with all the technology advances. And in fact, I think we're really in a renaissance period, if you will, between the human aspect of network cybersecurity and technology and the actual technology and software itself, meaning that we have opportunities in front of us that are we're going to talk about today that are related to how do we become more predictive in what we do, and we get away from having to just respond to things when they happen. So that's where we get into machine learning and predictive analytics, which again what we're here to talk about today. So I'm going to read through some of this just to again continue to set the stage of really what is cybersecurity, what is machine learning and predictive analytics, and how does all that stuff kind of help solve problems for those that are in the position to manage corporate or government networks and computer systems, et cetera. And so, and you guys are the experts, so I'm going to let you, respond to this. But basically, within the field of data analytics, machine learning is just a methodology. It's just one piece of it that through that complex, the modeling and the algorithms, they're able to drive prediction, right? And the predictions that they drive are based on patterns that they analyze. It's based on historical data and relationships, correlation of data, trends, and the list goes on. And the whole idea of predictive analytics through the use of machine learning is not really that it's going to tell you what the future is, right? It's basically just a forecast, but a highly accurate forecast because it's using these algorithms and complex models to dive in and do the correlation and establish patterns. And all of that allows us to get to this point of being predictive and having information we never had before that allows us to eliminate human error. It allows us to respond faster. And when you can do those two things, companies save money, they save lives, and they improve, the quality of the work that happens within, whether it's an agency, again, a government agency or corporation. So with all that being said, maybe I kind of open this up in the conversation to, let both of you guys maybe give me your perspective on what we have here as a definition of machine learning, predictive analytics, and then we'll dive into some questions that I have about it. Fair enough?
Sounds good.
Yep. So, just go for it. Nathan, if you have any comments you want to kind of jump into this, what do you think? Is this an accurate statement of what machine learning is and predictive analytics, or would you add to this?
Yeah, I mean, of course, I think it's a great foundation for, as a definition. And, when I think of machine learning, I'm often asked, how does it discover attacks, right? And then what does that look like? And to answer that or even begin to approach that question, I have to kind of look back at how it was done in the past prior to machine learning, right? So it traditionally, identifying threats has been a rather man-hour intensive effort, to make correlations between behaviors and nefarious files and improper uses on the network, right? And so now machine learning can take algorithms and identify those behaviors, and an example of that would be something like, something very simple. Let's say multiple attempts of a user ID to access the network from different places around the world, right? We know that it's impossible to get from Atlanta, Georgia to Beijing, China in less than an hour. So when we start to see those things on the network, using the machine learning, we can immediately identify that as a potentially malicious attempt to access the network. And taking that further, that machine learning and applying it to predictive analytics, I love the word that you used there, forecast, right? It's not predicting the future, but it's forecasting. It reminds me of something very relevant, in the news of late, right? Hurricanes. You look back at what was it, 1917, Nueva Gerona hurricane. It was the strongest hurricane to hit the Panhandle, until just a month or so ago, and it was devastating to Florida, right? I mean, it caused millions of dollars in today's stamp dollars of damage, and there were many, many, many fatalities. But what was different about it is that there was no warning, right? Back in 1917, there was no indication that a hurricane was coming. Here today, we know the hurricane's coming weeks, potentially, before it even happens, right? And that's done, via weather satellites and et cetera. And to me, predictive analytics is doing for cybersecurity what weather satellites do for us in terms of hurricanes, right? Like the weather satellite, the threat feeds that are out there, the services, I use the word threat feeds. You think of, threat intelligent databases, there's many of them out there, right? They're constantly scrubbing the web looking for, and even the dark web, looking for potentially hazardous or malicious files or things of that nature, right? Like a attack, right? Something
right.
Yep. I'll pause. Let Kevin jump in there. I get so excited.
Yeah, I don't have a lot to add. I think the definition makes a lot of sense to me, but I think a lot of folks probably saw the definition. You can Google about that. I think the harder part is to go beyond the definition and to see what is this and really works. How different is this from the previous generation technology, and how that apply to my security operations center if I'm a professional in the ops center environment. I think we can probably go through some of the both looking for the history as well as look at what happened and what's coming from the technology landscape and where we're going from here. So I think it'll be interesting to, as we conversation continue, we sort of make this kind of complex stuff, general discussion into something more relevant and more specific examples. And we can go, with the next 20, 30 minutes or so. Hopefully we can do that.
Yeah. So Kevin, you bring up an interesting point there about traditional cybersecurity defense. So how does that work in general? I mean, what are the challenges they have versus, today, for example, or another generation of technologies?
This is very interesting to think about what happened over the last 20, 30 years. This computer security industry has been evolving a lot, right? We all heard about the terms of such as 0 day. I'm sure everyone heard about that. Ransomware, viruses, spyware, and all sorts of terms. And let me go through a little bit of those kind of attacks and how we historically have been trying to address those kind of attack. Historically, a virus comes in, basically someone wrote some malicious code and they compile into something. You got to download it, or you go to embed in some website or advertisement, or it could be in a document. Whatever the reason, you got into a computer, and you get executed the code, and then just start doing some bad things on your computer, lock your computer down, or lock your keyboard, a monitor, or maybe your file system get encrypted. And that's actually, when that happens, someone might take advantage of that and ask you to pay for money for it, open the computer, or de-encrypt your file systems or your hard drive. And that's actually called ransomware, as example, right? So folks are looking for money as a return for the malicious actions they did by taking advantage of this viruses or malware they put in your computer or your network. And another, that's one example. Another example is, which is actually more serious, is something called a 0 day. And I know a lot of folks heard about 0 day, but I would assume not everyone really understand, or if you're not really a specialized in you heard about 0 day. What does 0 day means? 0 day usually means that there's some sort of defect or vulnerability in the computer system or software that vendor or whoever responsible for that didn't even realize. I'm not going to use a specific vendor here, but the concept is when you have a computer with an operating system or a software, whatever, and there's likely there's some defect or vulnerability existing that has not been discovered even by the manufacturer or by whoever want to protect your computer. And if this was discovered by folks who has bad intention and they discovered first, and then you realize after that, and the day you realize that is called 0 day. So it's really not the day that the hackers discovered. It's really it was a good intention. In many cases, the vendor or the manufacturer discovered that. That's actually the 0 day. You realize you have a problem. And then if you're 45 days later, that's called 45 days. So in case people didn't know what 0 day means. So why this is a problem? Because if you would even know this exists in your software, the software is used by many, many users or industries or government, and the bad actors discover first, they could take advantage of that and be able to using that as a way to get into your computer, your network, your data, and creating a lot of damages that you don't even know. And by the time you discover that, it's too late. And so this is all challenges, because of the existing computer and network. How we historically solve this problem? Because the whole cybersecurity industry go all the way back to antiviruses. When you had PCs, there was really no networking back then, and eventually people connected the networks together through the internet. And the viruses was more of a nuances. It's not a huge deal at the time, but it's getting worse. And the way antivirus software works is they gather all the viruses discovered and analyzing them and creating something called a signature. It's basically a way to identify this is a piece of viruses we have discovered and identified in the wild, and we document them, and then we put in the database. Think of this, one of the ways to think of this is basically a blacklist, right? And it's actually nothing different than if you think about the police, right? Police had the fingerprint of the criminals, had a criminal history at least. So if you got to scan your fingerprint, and if you got a match in your database, you are most likely a bad guy or potentially a bad guy. So you can get the rejection, right? And if you're not, this does not mean you're not a bad guy, but at least I don't know you're a bad guy. So it works really well for a while. But the problem is the hackers realize that once they're all in your database, they got rejected or detected. They say, why do I need to keep the same fingerprint? It's really not a real fingerprint, right? It's just basically code. I can make a small change in my code, and then the fingerprint change. Then I come back with the same intention, and you don't discover anymore. And then I basically be able to damage whatever I want for a couple of weeks, and you discover by the antivirus company, say, oh, this is a new variation. So I'm actually going to have to document this guy again, putting a new signature in my database. So my database starts with 100 entries. After a couple of years, I got 10 million or 100 million entries because the hackers keep changing them. And then your database is getting bigger. And now they're not only changing constantly, they can change on the fly now with the cloud computing, with automation. They can take advantage of those big computer resource, the hackers, and make changes on the code on the fly, as the signature to change it every single time. So the antivirus software will not be able to detect real time because at that point in time they even never recognize the fingerprint yet, and so it doesn't really work so well. So this kind of dynamics of someone inventing something, someone trying to document worked well for a while. But it's really not working so well, over the last, say, 5-10 years now. So people start to get more smarter. Say, hey, how do I solve this problem? So one of the ways to solve this problem is using something called a behavior-based analysis. Is not only I know your fingerprint, maybe you get into my network, my computer, I watch a couple steps you do, and maybe you have a better intention, more than just the signature, because the signature may be fine. And then I sort of base you into a network. The network is not my real network, but I sort of like a honeypot that you can let you behave a little bit. If you're not doing anything bad, I'm going to trust you and let you come into my real network. It works reasonably okay, but it doesn't scale so well first. The second is the hackers are very smart. They're recognizing they got into this honeypot. They will not act badly for a while until you pass the phase. Then you get in the real network, and they download the payload and start to do bad things after that. And then this kind of strategy works to some scale. It doesn't work so well. So now we got into trouble. Why? Because we got more data. We got a lot of much bigger network. We got more users, and attackers are using very, very advanced way to do that now. And we don't even have a way to scale to counter that because the hackers are also taking advantage of the advanced technology, the networking, the automation, the cloud computing, the scale, the speed, and now our strategy of relatively static way to get into using fingerprint or using some sort of behavior analysis doesn't really catch that because it's not fast enough. So you always get attacked because you just always behind or 1 or 2 steps behind them. So I think that's the big problem we see. So I think I'll leave it here for now. Just see you guys see where the challenge we have today.
Yeah, you know, Kevin, you're talking about the behaviors. I think that's one of the key advancements, right? And something that's worth digging into a little bit more. That fingerprint that you're talking about. You think about the example of a PowerShell script placed in a file, right? That database that we were creating before, the fingerprint was specific to that file and that PowerShell script now. But with the ability to monitor behaviors. The systems can begin to look for PowerShell scripts that have similar profiles, but maybe attached to a different type of file, right? That would have been completely missed before. And and it goes back to what you're talking about, the 0-day attack. It's never been seen in the wild in this form, but because of the ability for machine learning to to monitor the behavior, then we more effectively and faster be able to identify those attacks, right? And the known attacks, there's plenty of threat databases out there, and they're growing every day. but it is the new one, right? And with the speed of the ability to create them, it is a big problem. It's a very big problem. I read recently about based on the behavior that you're talking about, threat feed, for example, identifies a malicious domain that's indicating a spike in requests, right? But now, the new systems can correlate that spike in requests to a malicious domain to spikes in requests to unknown domain, right? And that correlation directly can lead to, I think you even said it, Kevin, I don't know that it's a bad guy, but I don't know that it's not, right? And if the spikes are directly related, chances are this unknown domain is, is malicious as well, and therefore the system can block it before the file or the user ever calls that domain, right? So preventing it rather than, being very, very good at looking back and determining what happened, which I think is where we've been, and what gets me excited about where we're going, right?
So that's an interesting perspective that you guys have on it, and you're obviously the subject matter experts at this. And so I have a follow-up question for you. It's related to this, but let me figure out how to really ask it to where it puts it in context. So if I'm in a security operations center, and let's define security operations center for today's conversation as cybersecurity, not physical security, even though in many ways these things get blended together a lot. But if I'm in a network ops center, let's say monitoring, managing the health of my network, intrusion, virus alerts, et cetera, how does this go about discovering the attacks? I mean, I know we're looking at patterns, we're looking at trends, but is it a new technology that has to be installed? Is it a software program? What is it that happens? What's the actual behind the scenes that's happening?
Yeah, so this is a very good question. So if you are working in the cybersecurity watch center or ops center, generally speaking, you're not necessarily a data scientist or machine learning specialist. And so this kind of a topic or terminology might feel a little bit foreign to you because that's not really something you deal with every day. So before we get into the specifics about the ops center, cybersecurity, predictive analytics, how we can really apply that, what kind of tools available, I think it'd be a good idea to actually just introduce a little bit what do we mean machine learning. People use the term machine learning, AI, and interchangeably, right? And,
well, that's right.
What's the difference between those guys? Because people don't, we sometimes take it for granted. We know the differences, but the folks are not really in the industry. They don't really know, exactly what do you mean when you say machine learning? What do you mean?
Yeah, because you know what, Kevin? Kevin. So like machine learning, to hitchhike on that, sorry, but machine learning is very complex. It's like an onion. You peel one layer back, you get more layers underneath it. I mean, you could talk in detail for 30 minutes on just deep learning or shallow machine learning, linear regressions and, gradient descents. I mean, the list just goes on, right? But kind of, if you could keep it general for us, tell us more about what that means. What is machine learning?
Yeah, so let me see if I can demystify a little bit about the machine learning. So when you folks walk out of this conference call or webinar, at least if you're not specialized yet on this, you can sort of, hey, I got some value out of this, and I want to keep it very simple, and I don't want to get anything very mathematical. Really want to make a very complex subject very simple to understand. So let's say, what do we mean machine learning? Is there some sort of magic happens right there? Where actually there's really no magic here. When we say machine learning, we're basically saying here is we are using a slightly different strategy to make a decision. And what do you mean about that? So traditionally, computer science is always, for years now, 50 years, it's mostly about logic. So when you're doing some accounting software, when you're doing something about travel, or you're doing your vacation, you're booking a ticket or whatever, there's a lot of logic behind it, right? So you want to fly here to there for how much price. The logic is basically relatively simple, I would say, or at least it's explicit. So the way a computer industry has been doing it is basically programming software using logic first. So if this happens, I do this. If this price is cheaper, I go that. Whatever it is, right? It's a lot of if-else logic with the data behind it to do this, but it's very much logic-centric. It's very, very much a handcrafted logic. So any logic human understand, programmer make them in a code so you can run the software to automating some of the behaviors human understands. That works really well. I would say works for majority of the applications we have seen so far. That's we had a very big success, and that's why people call the software is eating the world right now, right? But on the other hand, there's a huge amount of use cases. It's not like that. It's not like the rules are so explicit. You can write 100 rules or logic, you can solve the problem. And a simple example is image recognition. So I gave you an image. Can you tell me what's in this image? That's not really a simple way you can write some small if else, right? So you say if you have a pixel here, you do that. I mean, that's extremely complex because the pixels in the images, so much variation. It's almost impossible to write this kind of if else logic to solve that problem. Another use case is like a natural language processing. Can you hear something and just people talk with a different accent and the different languages? Can we actually write some code to automatically do that? The traditional software really doesn't work so well. So sort of logic, handicraft logic doesn't work so well. So there's a brand new way to look at this problem and say, hey, do we have a different perspective? It's not even just enhance a logic-based strategy, but using a data strategy. So what do we mean data strategy is get a lot of data about those examples. Then come up some sort of mathematical algorithms and use the data to train the algorithms. And eventually, after the training, you get some sort of model, which is basically nothing more than just basically some sort of math equations or model you can use. That in the new data comes in, you just apply as input, and you output with the new output. That's your prediction. So when we say, hey, what do you mean prediction? What do you mean forecasting? Really means is that you have had the opportunity to use the past data or sample data to train your math model. And then with the train the model, with the new input come in, you get some sort of output. That output is basically the prediction. If it's time sensitive, it's time based, you call them forecasting, right? That's in the future. But in general speaking, it doesn't really have to be time based and the forecasting and predictions. So in this case, let me summarize a little bit of what I just said. Fundamentally, there's a new way of looking at the problem is there's a set of problems. It's really hard. It's too complex. It's no real rules you can easily just document every possibility. Then a different way of looking at this problem is there's any way I can come some sort of mathematical model that are backed by algorithms. Then use a lot of data to train the model. I don't really know the rules. I don't specifically program in the rules to do if this happens, then I do that. I don't know that. But enough data give the model, if the model can actually learn from the data by tweaking the parameters, that's the term you have to know. There's some sort of parameters behind a mathematical model. When you have a model, there's some sort of parameter behind it. And what the training is really doing is basically after enough training, hopefully you get a nice parameter or set of parameters that you can use later when new data come in. You just combine the new data, the parameter, and the model to run. You get output. Then that's your prediction. That's your forecasting. And I hope I didn't try to use any mathematical term here, but I hope the concept makes sense to you guys. It's really not logic-centric. It's data and model-centric.
Yeah. No, I hear you. Did you want to add anything to that, Nathan? I've got a question, but I want to give you.
Yeah, I mean, thinking about how we experience that as a user. What I find in being in technology, I know too much about the underneath the hood, right? And it's hard to see what the actual car looks like. But you think about Siri, for example, right? When you pull your iPhone out of the box for the first time and you begin to talk to Siri. There's a lot of misunderstandings. Maybe doesn't pick up your accent, doesn't know some of the questions you're answering. But over time, the more you use Siri, the better Siri gets, right? And it's the same concept that I think Kevin's talking about here, right? It's that the model that's put in place is left open enough that over time it just gets better, and that is machine learning, right? I think in a nutshell to me.
Yeah, I agree with you. Basically, yeah, go ahead.
No, go ahead, Kevin.
Yeah, I would just echo what Nathan said is machine learning, if you're doing it right with enough training and the feedback, because this is really not a one-time effort, right? This is going to be iterations. There's a workflow here. There's iterations. Ideally, as the iteration goes on and the training get better and your model getting better, and you improve as time goes by, or more data, or more qualified data fit into the system, and your AI in this context, machine learning, is getting smarter, and that's AI is in action. If the AI, in this case, machine learning, is not actually improving, I think that's not really effective in this case. So it could start with something basic and getting smarter eventually. Yeah.
So a lot of people think of cybersecurity and attacks as being things that come from external sources. And when I kicked this conversation off, I spoke about external sources with Russia and Iran, and the other thing with the Under Armour attack. But I mean, is what we're talking about related to predictive analytics? Is it also applicable to insider threats? So in other words, if you have a policy within your organization that speaks to and addresses, external threats coming in, managing, monitoring, and trying to be preemptive with things, is that also covering the company's bases from insider threats?
Yeah, I think so. Because if you're looking at a perspective of machine learning and the predictive analytics perspective, it's actually not hard to think in a way that's input and output and a model. Okay, so think this way. So you have some sort of input, and the input can be anything. That could be your ages, how many times you download your software, how many times you log in, how many times you scan your badge, get in the building. Because we're talking about inside threat here. And those are basically input, right? So you can gather hundreds or millions of data, but the data may be manifest as various of attributes. The attributes is, for example, at what time you log into a system, how many times you log into a computer system, how many times you email to someone, or email to your system, your external email address. Those are basically attributes. So what the machine learning trying to do here is, if I can gather enough of this kind of attributes, which in the machine learning can call the features, then if I have a right model, I will output something. In this case, keep it simple. We basically have something. Is this behavior a normal or not normal? Is this a potential internal inside threat or not? Right? Because that in machine learning is called, which is called a classification, which is yes or no. In this case, a binary, but it can be more than one value. Is either you are a inside threat or you are not, or maybe with a probability you are 70% inside threat, based on my understanding of this data for the last 25 days of data I gather. So apply the machine learning paradigm in the inside threat context here. It actually works pretty well as long as you can gather those data with those attributes, and then you have enough data to train the model. Then there's a high probability the output, which in this case is the prediction, will tell you in a very high confidence that this specific data you gather is an inside threat or not, or with what kind of percentage of probability.
Yeah, no, I hear you. So let's just say, for example, a different question here. If I'm a company that I really want to get on top of my game here with this, do a better job at monitoring and managing intrusion detection and cybersecurity events that might be happening. What if I were the VP of technology, the CTO or CIO? What are some of the challenges that I would face, maybe trying to improve on what I have, or to even develop? Some companies don't even have a real cybersecurity initiative within their organization, so they'd be starting from scratch, right? So what are the challenges they face? Maybe what are the first few steps they would need to do to kind of get themselves acclimated to this and a program started? So that goes to
Nathan,
either
you wanna
of
go
you.
first?
I mean, yeah, sure. So there's many challenges. And I'd say from the technical perspective, you know, I've said for years, and kind of related to your previous question and then carrying into this one, you know, the user is the weakest link in your network or in your cybersecurity, right? And anybody in the industry has heard that, of course, you know, because we've got all sorts of firewalls and antivirus and, you know, DNS security platforms that are out there. I think one of the challenges is balancing between secure and usability, right? Think of an example, you know, going back to the idea of predictive analytics, you know, determining behaviors, right? And from a user perspective. So all of a sudden, a user who hasn't been on the network and doing anything after business hours, you know, for the last 30 days or even since they've, you know, been on the network, all of a sudden begins downloading large amounts of files at 11 o'clock at night or you know, after midnight, right? The probability that there's something going on there spikes, right? But then, you know, what to do with that is where the challenge comes in, right? Do you block that user? Do you take the analytics and take the probabilities and take action on it? Well, what happens when it's, you know, the CFO that's loading everything, you know, to the board for a meeting the next day, right? And you just block that, right? So you run the risk of creating inusable or hindering the user in the process, right? So how do you balance that? I think that's a huge concern for anyone in this, and, you know, doing this or standing this up, particularly for the first time, you know, and then also, you know, not knowing all of the systems that are out there and all of the different pieces and parts, right? The industry answer for, you know, 30 years, when there's an attack of a different type, what do you do for it? You create a solution for that, right? And you begin stacking these disparate systems that are doing a specific thing. And there's been so many different types of attacks, right? Whether it be from external, internal, from the desktop, from the network, you know, from the web, you know, all of these pieces and parts, they're not talking together, right? And so, you know, how do we bring all of that under one, you know, one umbrella and get all of the systems communicating with each other? Because, you know, until we do that, we don't have a unified front, right? We're defending effectively against a lot of different things, but when those begin to cross barriers, we're not defending against it because, you know, things are automated. And I think that's a real challenge coming out of the gate. Even, you know, that's a real challenge even for a well-established security operations center.
Mm-hmm.
Right?
Yeah. What's your take on that, Kevin?
Yeah, I think well said there. Let me add a couple of bullet points here. The first is I think the traditional strategy is still valid in many cases, but I think with the speed of changing, the scale of the data, and the automation the attacker is doing right now, they're not enough. I believe the machine learning and the predictive analytics is a great way to do that, to address this, but we are not mature enough yet as an industry to claim that predictive analytics will take over and solve all those problems, you know, tomorrow. It's not happening today or tomorrow, but it's happening now in a way that's speeding up. The reason is the whole thing is really not mature yet. If you think about it, right, when I say mature, it's more than just technology, really, is, as Nathan said. It's also the knowledge and the education and the infrastructure, the data, and the processes to adopt a new paradigm. And the new paradigm of using data as the center of decision and use the model as a way to run prediction to be more proactive instead of reactive. That's a huge paradigm shift. And let me go through each of them quickly to see where the challenges are. For and the most, I think is we simply don't have enough people even understand this stuff well, not really getting the details yet, because we don't even understand how a machine learning really is or works yet. And how do you expect someone, an operator, have no understanding at all to be able to take advantage of something that's advanced in a more of a operational environment? I think that requires some education on this, but there's only so much you can do with that, right? But I believe there's really a paradigm shift here. We need to educating our workforce. If I'm a CISO and I have to bring people who have that kind of data analytics understanding and augment with the operational experience together, we're not there yet from the knowledge, from the experience, from the workforce perspective. Second is we simply don't have the infrastructure. Our infrastructure is not ready yet. If you go to any company, I don't think a CISO actually has that kind of infrastructure architecture that can process a large amount of data ready for machine learning. And because that's usually historically the different departments' problem. That's not their problem. The infrastructure available on the cloud, that's true. But we don't have the infrastructure as organization infrastructure to take advantage of that yet. So how do you do large-scale computing to run this kind of machine learning and deep learning in a security team? They don't have the infrastructure. And the third one is, we talk about data here, are we? And the challenge is we don't have a lot of data that's available for us to immediately use high-quality data. We have a lot of data, but the high-quality data, in many cases, data available, labeled data for training of the model is not there. And the second is, historically, the security industry, cyber, is not very famous for sharing data because that's the hope. It's counterintuitive to share, right? And if you don't have those data and the intelligence is not there for you to train the model, and the model is limited. And the fourth one, I think, is the problem of the machine learning industry itself, is the technology and the model. There's way too many algorithms out there. If you really get into the details of machine learning, you realize there's so many algorithms there, there's so many parameters, and there's also something called a hyperparameter you have to tune. And I mean, people don't have the skill set and the technology to make that happen because it's really not like one button clicking since it will work. There's a lot of tweaking. It's still not automated. And the technology is stacks not mature enough for an average guy to take advantage right away. So with all the stuff together, yeah, it's not easy. This does not mean it's not working. It just takes a lot of effort to put all these pieces together. That shows the maturity of this whole strategy we're talking about here. Requires a couple of years maybe to reach to a level the average guys can take advantage. But there's a huge potential, I believe.
Kevin, you said something in there. There's just not enough man hours, right? It reminds me of probably one of the most famous cyber attacks with Target, right? Remember that was a breach that came from a van in a parking lot. But the forensics after the fact show that there were malicious files on the network for over 3 months, right? And multiple alerts were hitting their team that there was a problem, but they just didn't have enough man hours to make the appropriate manual correlation, right? And for any organization, those participating here, or any that we interact with, you just for a second step back and compare the size of your team to the size of Target's team, right? A large enterprise, fully staffed, doesn't have enough hours, right? And so, for me, when approaching this challenge, it's imperative to reach out and not be afraid to, pull in the experts. Even if you're building your own SOC and staffing it yourself, and you've got the man hours, or you've got the people, you've got the knowledge in-house, it's impossible to know it all, right? So leverage consulting and outsourcing to enhance that effort, right? For me, bottom line is, that you've got to assemble a team of experts, both internal and external, in order to be successful in this, right? Because there's no way any one of us, or even any team of us, can know all of it.
So I don't know if that was a question back to Kevin or not. Was that a question to Kevin, or just a comment?
No, I was just adding on to what he said. It really just thought, so.
Yeah, no. I mean, good points here. It's a fascinating conversation, and I'm sorry to say it. Just the last 45 minutes have flown by. I mean, we're here at pushing an hour, and we're going to be wrapping it up soon. So I could honestly listen to you guys for a long time, and I've got some questions here that have been sent in. So I want to have an opportunity to talk about them. So one of the questions that came in was, can you set policies or triggers around machine learning? And I'm assuming that is a question kind of related a little bit like policies and things that you might set on Active Directory. I'm assuming that's where it's going, but do you understand the question?
Yeah, I do. I can take that one. You know, it kind of reminds me, I'm often asked in the world of machine learning, right, as we move into this, do I lose the ability to control policies, right? And, you know, we've talked a good bit about, you know, how manual the historical process is, right? And we're, by and large, creatures of habit. We have invested in the education and the, you know, the knowledge of our teams, and we want to maintain control of that, right? To be perfectly clear, you know, machine learning does not replace that, right? Policies and triggers are still in place. Think of the example of a policy of the past. A user in sales, for example, is all of a sudden in accounting trying to access, you know, payroll files, right? That's a violation of a policy, and it triggers an alert, right? Machine learning doesn't replace that type of user-based policy. It supplements it, or even, you know, ideally with the right amount of data, automates it. The administrator, however, still maintains the control. You know, or think of it another way. You know, with HIPAA and PCI and, you know, all of the different types of legislative policies that we have to set, as those change over time, we have to maintain control of it. So it's not an either or. I think they work in tandem.
Mm-hmm. Mm-hmm. So do you have anything on that one, Kevin? Do you want to add to that?
I agree with what Nathan said. I think the complementary thing is correct, and the duality is you can even challenge it to see, in some cases, maybe not necessarily the highest level policy level, but at the operation level, some of the threshold is dynamic. So it really should not be single or static. I know because for simplicity or historical reason, we set something as a static, right? But the reality is those threshold probably should be dynamic and adaptive as time and the situation changes. And this is where machine learning can come in to say, okay, instead of using 100% rule-based strategy, which in this case is a basic threshold, if it's more than threshold, get a red dot on my screen, right? So that's actually a threshold. This number does not change. Why don't we change to a way that if in this situation, the threshold is 20, and in some other cases is 40, they're all valid. That's okay. And that's actually we're going to take us to the next generation of being able to adaptively address the situation in the cybersecurity to understand what is normal, what is not normal, abnormal, in what context and situation, more with beyond the one single data point, but a set of many data points driven by the model and the correlation to understand what is normal, what is not normal.
Mm-hmm, mm-hmm. I got you. So another question that came through is, you know, is an audit the first step in understanding? I think the answer is yes, but there's a second part of the question. So is an audit the first step in a overall bigger initiative of cybersecurity for an organization? And if so, the second part of that question is what's involved in the audit? What would be some of the key things that an audit would look for and extract from a process of auditing that might provide insight into vulnerabilities and areas of improvement? And that's to either of you.
Yeah, Nathan, you want to take that one?
Yeah, that's a big question, right? Yeah, I mean.
Well, let's start. Let's do this.
Absolutely. Audit is the first step, right? You need to understand where your weaknesses are. But you know, I mean, to unpack that question, we probably need another webinar.
Yeah. Okay. Well, maybe we could do that. So let's simplify it. Let's say, so an audit is really a first step. That's kind of like makes sense, right? But what would be a few things that you would look for in an audit? Would it be external an external testing, if you will, of a network to try to find the vulnerabilities? Is that one of the audit, the criteria that you use for auditing?
Yeah, I mean, we call those, a lot of times call those penetration tests, right?
Yep.
And it is a matter of banging on, for lack of a better way of putting it, on the network and seeing if there's a way in, But there's one of my engineers I respect greatly. He always said that a penetration test made him laugh. He said, because there's always a way in, right? You can always find some vulnerability, right? So for me, it's bigger than that. It's a matter of finding as many as reasonable within the effort and the time that you're trying to do, but then prioritizing the severity of them, right? It can become overwhelming, right? If you look at truly what what your vulnerabilities are. Going back to even what Kevin said earlier with cloud computing and the speed that attacks are able to morph these days, you could put yourself out of business trying to just keep up with making the investments in your security system. So how do you make those decisions? And I think that's probably step 1A of the audit is working together to try to figure out what do we do from here.
Yeah. So let's move on to another question here. Looks like the final question, honestly. Are social media platforms more vulnerable than the computer network? Well, so they're all part of a computer network, but I guess what they're asking is how vulnerable are social media platforms versus maybe some other kind of communication, email, or other ways that hackers are able to get in. I'll throw that at you, Kevin.
All right, so let me answer that question. As you point out, there are digital way of communication, emails or social media. So they're all, if you look from a security perspective, they're all dangerous actually. Generally speaking, you should not trust anything, right? I think social media, in that context, social media has a problem is because you, generally speaking, are receiving the data from your network. If you're LinkedIn or Facebook, if your family, so extended family, they actually implied some sort of trust there, and that gives you a possibility that you trust something come to you or something has been validated. Sometimes it's not, and you may be tricked into click a link on the website somewhere or click download a document, and which actually has a microscript, inside embedded, and you'll be tricked using some sort of social engineering to do something with it, and that will actually cause a lot of problem because you basically open the doors for the virus is going to download to your computer or to your network. That's sometimes you less likely will do if you just get into a website somewhere because you don't know, you have no idea about that. But beyond that, there are underlying attack or strategy they're not drastically different. It's more of the social engineering and the trust side of this that actually makes the social media, I think, has become even more risky in this context.
Yeah, I would agree. I think from a social media perspective, people are a lot more casual with what they do than maybe on a corporate network, right? So I would think that that's a lot more vulnerable. It's interesting, we have a webinar coming up here real soon about social media listening centers, and social media listening centers are doing more than just monitoring what's being said out in the marketplace about a brand that, for example, it could be, NASCAR, the Red Cross, it could be Coca-Cola, or anybody else out there who wants to understand more about what's being said about them in the marketplace. But they are also managing and monitoring, the impact that social media is having on the potential for risks for their company at a broader scale. We kind of wrapped up the three questions that we had, and I don't see any others coming in. So we've either put everybody asleep or we did a really good job at of describing what we came to talk about today, and that is, how predictive analytics and machine learning is changing how companies and agencies are working around the cybersecurity problem that we have. And it's an unfortunate problem, but it's one we have, and we're probably going to live with for a long time. So we've got to get really good at it, right?
That's right.
Yeah. So with that, gentlemen, I want to just say thank you for joining us today, and thank everybody else for joining us. I hope it was helpful for you. And as we kind of wrap up here, if you are interested in picking up a copy of Citscape's white paper on cyber analytics, you feel free to shoot me an email at rcameron@diversifiedus.com, and I'd be happy to get that out to you. But go to our website. You can find other webinars we've done in the past, and we're doing these every month. And so we have different topics that are relative to the mission critical environment, which would be your security operations centers, network operations centers, and anything that has to do with managing the mission critical aspects of a business or a government agency. So please do go to the website and take a look at what's coming up. And again, thanks a lot, everybody, for joining. And with that,